Why does the giant squid have ammonia for buoyancy? Imagine swimming in the dark, crushing depths of the ocean where sunlight never reaches. How do creatures like the giant squid stay afloat and move smoothly in such a harsh environment? Well, it turns out they have a clever trick involving something you might think of as a waste product: ammonia. Most deep-sea animals face a big challenge. Their bodies are heavier than the surrounding water because of proteins, muscles, and tissues. To avoid sinking or floating uncontrollably, they need a way to balance their weight. This is where the idea of neutral buoyancy comes in. It means they stay at a certain depth without using much energy to stay there. For the giant squid living between 300 and 1,000 meters deep, this is a must-have adaptation. So, how does the giant squid do it? It uses ammonia, a chemical usually considered a waste product from its metabolism. Instead of getting rid of it right away, the squid stores ammonia in its tissues, especially in a large cavity called the coelom. Ammonia is much lighter than the sodium ions it replaces. Sodium ions have an atomic weight of 23 atomic mass units, while ammonia ions weigh just 18 atomic mass units. This difference makes the squid's tissues less dense overall. The squid carefully controls how much ammonia and sodium it keeps in different parts of its body. Its main body, called the mantle, has the highest concentration of ammonia, while the tips of its arms have less. This setup allows the squid to fine-tune its buoyancy, making sure it stays balanced in the water. The ammonia mixes with chloride ions to form a solution that is almost the same saltiness as seawater but is less dense. This solution is stored in the tissues and acts like a natural lift, helping the squid float effortlessly. Interestingly, this ammonia-based buoyancy system has evolved many times in different squid groups. Scientists used to think it only appeared once, but recent studies show it has appeared at least 9 times in different deep-sea squid species. This shows how effective this method is for survival in the deep ocean. Since ammonia is a waste product, it might seem strange that the squid keeps it. But over millions of years, they have learned to recycle this waste into a tool for staying afloat. Instead of releasing ammonia into the water, they sequester it in their tissues, turning a waste into a survival advantage. Now, you might wonder about pressure resistance. The deep ocean is full of crushing pressure, but the ammonia solution inside the squid stays stable because it is a liquid, not a gas. And like a gas-filled swim bladder that would collapse under high pressure, the liquid ammonia solution remains intact, allowing the squid to move freely at different depths without risking tissue damage. This liquid-filled system also keeps the squid's body uniform and stable, preventing any weak spots that could be crushed by the immense pressure. Using ammonia for buoyancy is also energy efficient. Instead of constantly swimming to stay afloat, the giant squid can drift slowly through the water, conserving energy. This is especially important because food is scarce in the deep sea, and conserving energy helps the squid survive longer. In conclusion, the giant squid's use of ammonia for buoyancy is a perfect example of how marine animals adapt to their environment. It helps them resist pressure, stay balanced, and move efficiently in the dark, deep ocean. This adaptation shows how clever evolution can be, turning a waste product into a vital tool for survival in one of Earth's most extreme habitats.